percentage, the maximum and minimum, the range, or just count the data rows in each group. The node that performs aggregations is the group by node. So let's create a group by node. Here I have my adult data set again. Let's say that I want to calculate the average age for the male and female in this data set. So let's open the group by configuration window. And here in the Groups tab, we select the groups. The groups are male and female, so they are identified by the values in the data column sex. Then we move to the manual aggregation. We select the column age, and for the column age, we choose the aggregation measure mean. So we calculate the average age. I could have calculated many more aggregation measures, like for example, the standard deviation, the last item, the last value in the group, the geometric mean, the first value in the group, or for example, just the count, the counting of the number of rows in that group. So let's execute. Let's see. So I get that female average age is 37-year-old and the male average age is 39-year-old, at least for this data set. Let's count now just the rows. So instead of using the average, we use the count measure. The count measure just counts the data rows, which means that in theory, it's independent of the column that we have chosen. The number of data rows for the female is the same if I count them on age or if I count them on work class. This is true without the missing values. However, I can take care of the missing values. That means I can include the missing values in my aggregation measure as well by clicking this flag here. So let's run it. And here I can see that the female, they are 10,771 and the male 21,790 in this data set. This kind of aggregation is nice, but of course it works manually only for a low number of data columns and a low number of aggregation measures. If I have many data columns and I have many aggregation measures, then I need to use one of these two tabs, the pattern-based aggregation and the type-based aggregation. The pattern-based aggregation allows me to use the wildcard search for the name of the columns or the regex search for the name of the columns. For example, I want to search all the data columns with name starting with EDU using the star wildcard. And for all of them, I'm going to select, for example, let's say the last. So the last value in the group for all the data columns with name starting with EDU is going to be produced in my resulting data table. So let's remove this rule. If I want to define an aggregation measure for all the data columns of the same type, for example, if I want to define an average for all the double type data columns, in the type-based aggregation tab, I can just select number double and then the mean aggregation measure, or for example, something else, or the standard deviation aggregation measure. And then I calculate the standard deviation for all the double type data columns. Now here, we have calculated the number of data rows for each group in the sex data columns. Let's suppose that I want to calculate the number of data rows for all the female earning more than 50K, or the male earning more than 50K, or the other two classes, female and male, earning less than 50K. So this second dimension of the group is in income. So here I group by sex and income, and I calculate the number of data rows in each group. So let's see what comes out of that. So I have that the female earning less than 50K are 9,592 and so on. So I can count the data rows for each one of these groups. Now, this is nice, interesting information, but it would be nice to have like a pivot kind of format. So I would have here the classes for the sex, female and male, and I would have here on the column headers the income classes, so earning less or more than 50K. That's what people are used to. There is a node that does that, and it's the pivoting node. The pivoting node calculates exactly the same things the same aggregation measures and isolates the same groups like the group by node, but the shape of the output result is different with respect to what the group by node produces. So here I have group, pivots, and manual aggregation. So let's find my men and women here. On pivots, let's find my people earning more or less than 50K. And then let's calculate the number of data rows included in each group. So now let's run it. And now you can see that the numbers are the same that we found before, but the organization of the result is in a pivot-like matrix, which is what people sometimes want. So the pivoting node has 3 output ports. The first output port is the pivoting matrix. Then the second output port contains the totals by row, and the third output port contains the total by columns. Always keep in mind the group by node, because the group by node, together with the file reader node, can likely solve 90% of your aggregation problems.